I know how to cobble things.
All right, I'm at PMAS, and what they do is they specialize in airflow. So these guys are. I mean, I got my idiot friends. They're doing dumb shit.
I'm pretty sure you just
put it on top. You need to how do you tape this down?
hold it still. Thank you. We just do this a whole bunch of times.
So it's amazing what you can do with duct tape.
Right.
And these guys actually flow stuff all the time like this, and you wouldn't think it works, but it actually does. There's nothing wrong with it.
Not a damn thing wrong with it.
Nothing.
Scrounged up a tripod. Actually, you did. So, but I'm sitting here with Nick, and so Nick runs PMAS. Nick, tell me about PMAS. What do you guys do?
So PMAS.
Sorry.
Close
do
enough.
I need to? Do
We've
I
only
need
known
to?
you for 30 something years.
Wait. Well, let's restart
You
it.
gotta leave
No,
that
no.
in. You
All
totally have to leave it in.
All right.
So mass airflow company. So we build mass airflow sensors, performance automotive mass airflow sensors, mass airflow sensors for lab grade systems for measuring airflow and engine dynos. We've built them for supercharger dynos, just sensors to measure airflow. We also, in 2015, started making cold air intakes, so we also make cold air intakes. Not my most favorite thing to do, but most of the stuff that's out there is just utter garbage, so we had to fill a void there, so we started making some stuff like that. A lot of those also use mass airflow sensors, but mostly testing, airflow stuff, things like that. We got people, OEMs send us stuff to get tests done. We tested throttle bodies for companies, Ford hydrogen fuel cell programs. We've done a lot of random stuff over the years.
Okay, so now in addition to you doing that stuff, like lab services essentially, you said you also do cold air intakes. Is there a specific application that you guys are really well known for?
Mostly Ford.
Okay,
Mostly Ford, yeah.
So every Mustang guy watching this knows who you are probably?
Hopefully.
Hopefully. All right, so if they don't, hopefully they will.
Secret undercover shit.
See, yeah, so Warren is here. I didn't know he was going to be here, but he's flowing some fittings, I guess.
Fittings and there's a lot of junk.
Everybody flows fittings.
We'll find out and see if these banjo fittings actually do anything.
Oh, you mean if they're a restriction or not?
Yeah.
Okay.
We're gonna see if that's the case. We've got a whole box full of fittings and of course Home Depot stuff.
Home Depot racing, baby. That's the best. Don't even hate on that.
You can either just cut them and shove the ends in
to
them
mount
or
it.
glue them or whatever it is. And then we can kind of see if this is a restriction versus that or a bend or anything like that.
If you do the hose, you can extrapolate that. You can be like 1 foot is this much restriction, 10 feet is this much restriction.
And I got a whole box full of fittings. You do like number 10s, 6s, all kinds of crap. So, but eventually what I want to do is I want to build like a plate with bungs on it, and then we can just screw the fittings on there. Are you recording?
Yeah, of course.
Some people have become learning.
People gonna get learning.
We're doing, learning with a group of idiots.
Yep, pretty much. Then the last part is we're gonna flow Ram Kumar's stink pipe because it needs more resolution.
Is that is that a bong? What is that?
So that's gonna be a fun one.
All right, cool. So I actually came here today to do some testing on one of the velocity stacks that I made for the Jeep. Ran into a few of my friends. We've all been friends for a long time. I've known Nick for a long time too. But essentially, this is your big flow stand in the background, and this is your workhorse, right?
That's the big R&D stand, yeah.
Yeah. So this is what you essentially do. Any sort of random weird projects that come into the shop.
Yeah.
It goes to this. So can you give me an idea of like what it is?
Yep. So it's a lot different than most people think of an airflow stand. They think of it like a Superflow 600 or a Superflow 1020 or something like that. This works a lot different. How those stands work is they'll crank up the airflow till you hit 28 inches of restriction, and they tell you what the flow was at that restriction. That number, Smoke Unit picked that number years ago just because people needed a reference. They needed to pick something to measure from to say this part flows this and this part flows more or this one flows less. So you got to have a standard. 28 inches is the standard. So Superflow, they run it up till it hits that and they say, okay, it took 1,000 CFM to do that. This one kind of works in a different way. It measures multiple points. It's more of an engineering stand than like a engine development stand. So we'll float a whole bunch of different airflow points, tell you what the restriction was at each one of those points. So it's a multi-step test. It tells you way more information than like a superflow. Instead of having one data point, you get 37 in one of our tests. You actually get this little curve of flow versus restriction. Speaking of something like a superflow, their biggest stand flow is 1,000 CFM. This one knocks on about 4,800, 4,700 CFM, so massive. It will do well over 3,000 horsepower worth of airflow, so we can do tests for anything automotive for sure. Getting into way big stuff, big diesel stuff and things like that. So, so we can pull about 4,500 CFM at about 80 inches of water for tech savvy people that know what that is. It does a lot of suction.
Yeah. So at the end of the day, you have a test done on this, and you get a sheet of paper that looks kind of like a dyno graph.
Yeah, a little bit. And that's the other thing, too.
I should say like an old school dyno graph. If you remember old Superflow engine stands, you would get like a
yeah, kind of.
spreadsheet.
It is like an old spreadsheet, like an old Superflow 901. Is that your camera's off? Still working?
No, it's, okay, it's
good.
still on, yeah.
Yeah, the other thing, too, I don't want to forget that this is a NIST stand. So this stand is certified NIST. This is not something where you can adjust knobs to tweak outputs and things. It goes off
It's not a dyno jet?
Yeah,
oh,
no.
man.
So a very, very important government agency called the National Institute of Standards Technology measures this, and they certify all the equipment on this thing and say that when you get this number off the stand, this is exactly what it is. And in our case, I'm within 0.15% of reading, which is unheard of. The only way to be more accurate is to be NIST themselves. So no way to be more accurate. So this thing is super, super precise. They're gonna leave them together.
Flow that other one that's got, this is 120, right?
That looks like a 120, yeah. So that banjo fitting is supposed to flow a lot of air. You can hear that it doesn't.
It's gonna be rough.
Okay, so you guys are here for like an interesting test today. So normally people want to test their airflow. That normally they take, like, this is actually a pretty interesting thing, but it's not even why you were here today, really. It's another test that you did. But one of the things that PMAS does is they will actually sell just this block, and they will also sell a calibrated air sensor, which is this part of the air sensor. So you've actually got this on your Colt, your free candy, right?
Yep.
What do you guys do with it?
We look at this as more for data. So if we can measure the airflow that is in a pipe or in your system, you can actually measure how much horsepower that is. And that's invaluable data because it's actually measured load. You're not guessing what your load is. So PMAS offers mass air sensors that you can calibrate from anywhere from 800 horsepower all the way to 3,000 horsepower. Is that right, Nick? About 3,000 horsepower or so?
Well, and they can do pretty much anything too. Like if we needed more than 3,000 horsepower,
We could make a 12-inch mass airflow sensor that flowed 8,000 kilograms an hour, technically, if you needed something like that. I know a lot of people making.
What's the biggest mass air sensor you've ever calibrated?
I think it was, 14 inches in diameter.
14-inch diameter. So
For a
was
big
this,
diesel thing.
So basically, I mean, in the race world, we deal with some big stuff, but we don't deal with 14-inch mass air sensors.
6-inch inlets and stuff is like the most you see in like automotive, even diesel pole stuff.
Yeah. So
We do a lot of diesel pole stuff.
So PMAS provided the sensor, actually calibrated the sensor, and so like you guys ended up with the data to plug into your standalone, right?
That's right. So we're going to be using all the information that Nick provided on the 37-point flow, which gives you a voltage and a specific flow value for that. When you put that in Haltech, because we use a Haltech system, we can now have that information where we can say, you know what, if I'm going to increase the boost from 30 to 50, how much increase in horsepower is that really equal to? And that's good information to have, because if you are at the limit of what your charger is, let's say I want to go to 80 pounds of boost, if I have that in correlation with my turbo shaft speed data, I can know that I'm approaching the limits where I might be breaking my stuff, or I'm approaching the level of breaking it, and I don't want to reach that point. So
Without actually having any gains.
exactly. So it's just pumping a whole bunch of hot air into our system, and we don't want it.
So you have, you do have the ability to look at map sensor, but that only tells you so much, right?
Correct.
Okay, so, and actually on the Haltech, if you were like on a more street application, you can actually change the Haltech in the NSP version of Haltech. You can actually run off the MAF sensor.
That's right.
Okay.
That's
Or a
right.
combination.
You can
could
work on a blend as well.
Well, and a blend, and you can also build the VE table with the math. So, for example, you just wanted to use it to build your speed density VE table. You could use the math for that, Because when you have a MAF, you have load. You have VE. It's a VE sensor.
Yeah.
So you could use it to build your table in and plug it when you're done, or leave it in as a horsepower meter and save some tuning time. Not a lot of people are doing that, but they're starting to.
So the equipment in this is government calibrated.
Yeah, like this thing costs more than most houses, for example. For a flow stand like this, you'd substantially more.
Yeah.
So, but yeah, the government says this is an exact number. There's no numbers to tweak. There's no fudging when it comes to this. This is a very precise piece
So
of equipment.
you took all of this lab grade equipment and you're making Mustang mass air sensors with it.
Yeah, pretty much.
Okay.
Because that's what it takes. You know, it takes that kind of equipment. Unless you're Bosch or Hitachi or one of those people, if you want to make mass airflow sensors, you need something like this. So we had to do our own to do that kind of thing. So yeah,
Cool.
It'll probably never pay for itself, but it's a pretty cool piece of equipment to play around
Yeah.
with. That's
Well,
for
I mean,
sure.
and that's one of the reasons that you guys do other things than just Ford air meters with it, right? So,
Exactly.
So the people who buy your sensors, they can actually get either custom calibrate. They can buy performance-oriented stuff right off your site, right?
Yep, they can get ones that are ready to go that are set up to cover a certain horsepower range. That are pre-calibrated and they have a specific range, and you get a printout sheet, just like an old dialograph that says, okay, here's the flow and here's the MAF output, and that's the data you need for your standalone or your tune and your ECU or things like that, and you get that.
So you can order, like if you're a guy with a Ford, you can actually order straight off your website. I can get a sensor that I plug in and it works.
Yep.
Or I can get a sensor that's higher performance.
Yeah, it has
Yeah.
more range. So
More
that's-
range.
Most people, the reason they replace their mass airflow sensor is they've pegged the original mass airflow sensor. So, for example, like an old Fox body Mustang, they came stock with them, and the cars were 220 horse-ish. The stock MAF would run out of steam about 260. So if you want to make more than that,
That's
you had no options.
Yeah,
You
pretty
needed
low
to,
ceiling,
yeah,
yeah.
you had to change the MAF. So that's where we got into it. We started making MAFs that had more range, so you could put superchargers and things and still run on the factory ECU without having to go to standalone. Because back then, you want to make more than 260 horse before a modified MAF, you were putting back then it would have been a Excel DFI on it probably or
Okay.
something is what it would be, and that was your only option. So you're trying to make 300 horsepower, you can buy a standalone.
Yeah.
That's ridiculous, but so MAF solved that.
I'm
MAF
surprised
was
guys
good
didn't put
range.
AFCs on them.
Yeah, they did that
I
too.
was gonna say they probably could
But they
have.
still peg the math because
Yeah.
you got 5 volts and
Yeah. And I know that you're all about data, so
right.
I mean,
It's all
not
about-
as much as I am about data.
No,
but
you
it's
love
a
your
di-
data. But here's the thing: if you have enough data, then your tuners or your calibration specialists are
calibrator. That's a fancy word for tuner.
can
Wow.
now may have more informed information to make wise decisions, so that your stuff doesn't blow up.
Jeremy, how's that worked
How's that
out?
going for you, Jeremy?
We're still trying to prevent that from happening. That's the bigger problem.
Well, here's the problem. I know how Warren loves his hero passes.
I do. I do.
So, but okay, so we kind of went on a tangent here. You didn't actually come here to do this. You actually
No.
came here to do something else, which I've never heard of anyone doing. And I'm sure there's some guy who's done it somewhere. But tell me about your project today.
So, well, we'll start off with our project from our race director, Kevin Kwiatkowski from Antilag Racing. He informed us that we need to do our homework. And one of our homework assignments was to determine if the fittings that we were using to alleviate some of our crankcase pressure were restrictive or not. So the thought was, well, how are we going to empirically measure how if something is restrictive? Well, our good friend over here, Nick from PMAS, he's got a flow stand that can tell you how restrictive something is. So we decided we're going to bring an entire box full of AN fittings and lines and determine how restrictive stuff is going to be. So we have fittings in various sizes, things that folks would normally use, whether it's PTFE, whether it's a tight 90, whether it's a free-flowing 90. How well does a banjo fitting flow with 24 inches of line?
Restriction does just a hose do,
Yeah.
based on the size, along with the fittings on the end of them. Whether you have a combination of, say, a 45 with a banjo versus a straight and a banjo, or a straight and a 120, based on the length of the line as well, to see if there's an increase based on line length, fitting size, fitting type. And yeah.
So you guys basically started out, it looks like you got some 12 AN lines here, and it also looks like you got a bunch of 10 AN fittings. So can you tell me a little bit about your process?
So the first thing that we had to do with any test is you need to have some data, right? Which is going to be the most restrictive piece that you think is going to be in the system. So for us, we started with this one. We're like, well, that looks pretty restrictive. And we're going to pick a flow value and see what it does. And I think the number was 100 kilograms per hour.
That was the max, yeah.
That was the maximum.
64 kilograms per hour is what we kind of ended up using as the general.
Which is about
flow.
50 CFM. So you move 50 CFM through this, and we measured what the actual flow was through that and what that restriction was. So just like with anything at PMAS, you're going to get a 37-point curve for your 90-degree fitting if you choose to flow that.
All I'm saying is it's a good thing you know Nick, because this would cost a lot of money.
It would cost you a lot of money.
If you brought like 10 random fittings to
If you think about how
a lab.
well, you couldn't even do this kind of thing on a super flow, because the super flow just tells you what the flow was at a given restriction, right? So
Correct.
everything's at 28 inches because smoke unit picked that random number,
Yeah.
and that's what's stuck. So what we do is a little different. Instead of saying here's what the flow was at 28 inches, we say at this flow it was this many inches, at this flow is this many inches, and you get to build a whole restriction curve instead of just knowing what this random point is. So you kind of get a whole shape, but you can also find out what it was at 50 inches and what it was at 60 inches or what it was at 10 inches, for example. So you get a whole bunch more data. But yeah, if you had to send this to a place, they'd spend 3 hours for one flow. So the way the stand works is we can do that a lot faster, a lot more automated way. But this test would have cost them $15,000 at a
$15,000,
Yeah, at an
and
RV
you
place.
get that for free.
You get that for free. Anyway.
But yeah, so we have a really
Well, he did have
cool-
to buy lunch.
We have a cool
Yeah,
machine.
I-
Oh yeah,
lunch.
yeah, he did buy us all lunch, so yeah.
And some beers.
So to get this kind of down is really complicated unless you have a specific machine designed to do this, which we have.
Okay, so you did this fitting. You did a bunch of other fittings. Now you've got that looks very scientific.
Very scientific.
It doesn't have hash marks.
I don't know if I
No,
know
no.
that part, but yeah.
Yes. So after we flowed all of these setups, and some of these setups are actually on the real world car, on the Colts. And what we found these styles of fittings to be extremely restrictive, right? Now everything with airflow is always relative. You have to have something that you're measuring against, right? It's like it's how restrictive is it compared to what is your datum. So in our particular case, this was our worst case scenario. Our best case scenario was just the hose.
Yeah.
A hose with no fitting. That was actually
Actually
larger.
flowed the best.
Actually flowed the best. Now what we did find was, which was the most interesting one for you?
Well, this one.
No, the long radius versus the hard 90.
Yeah.
difference
So,
between the
well, a long radius at 120 degrees compared to,
This one here.
yeah, there it is. The one with the 90. So not only do we have a longer hose, the only difference between these two is this hose is a little bit longer. This is a longer radius versus the 90-degree, well, banjo style. And this one was barely more restrictive than actually just a free-flowing hose, whereas when you did a hard 90, which is kind of the theme of all of this, it seems like, any of the hard 90s, the restrictive levels just went through the roof as
Yeah, like
airflow
that
increased.
120-degree bend, which you would think has a whole bunch of bends,
Yeah,
it's
yeah.
way more restrictive because this only turning 90, right?
Yeah, but-
this was considerably
But
more
the
restrictive
hard-
than this.
The hard 90 versus a kind of a
and
mandrel bend versus
Where-
a gentle bend, if you want to put it that
no,
way.
a long radius 90 compared to the short radius.
This one here.
So it seems
Yeah,
like
so-
in general, the
that
the
one-
tighter the 90, the more restrictive it is.
So, yeah,
it's been pretty
So
universal.
this one,
I
for
think.
example, they're both 90s, right? It's long radius. Everybody knows that helps. How much
half-
does it really
half
help?
as
This is
restrictive.
at half the restriction of this 90.
That's
like half
wild
the
because
restriction.
these are. I
Massive
think Warren had
difference.
mentioned these are actually marketed as being full flow.
Yeah,
Correct.
And basically, as far as airflow is concerned, there's no way.
Yeah.
Like not remotely. It's half the flow through that with air.
Yeah, I mean, if
Now-
you think about it in the inverse, yeah, you could think about that. This would flow twice what this would at the same restriction, which is insane.
Yeah.
Because it's the same size, same turn.
Do you think there's any possibility that they flow nearly the same on an incompressible fluid?
Yeah, they would be a lot closer
Okay.
because it's incompressible. So the size matters more than the shape of the turn and how the turn.
So the problem is Warren is trying to use a fluid
Water-
fitting
for air.
For air.
Yeah.
And a lot of us do that. And in fact, I would say most people who get drag racing, especially in small displacement stuff, when you start making your own breathers, puke tanks, and all this other stuff, you're using a bunch of fluid fittings for air, which technically air is a fluid, but like it's different. It's so really the lesson that you learned today, just very high level, is bigger is better, straighter is better.
The lesson for the day is that the best hole is a hole without a fitting. But that wouldn't be any fun because we love putting fittings in holes. Take that however you like.
Oh, Lauren.
So I can do stock replacement, I can do performance oriented, and if that's not enough,
What's one-off stuff? So.
You'll do one-off stuff. I think you posted a month ago now about like a real fast Mustang.
Yeah. So there's two of them now. So
Okay.
two guys now, and they're Coyotes, and they're running 6s at, I think he went 215. And not only is this running the engine with the MAF sensor, it's not speed density, they're still running on the stock Ford ECU, which is insane. So they're running one of my MAFs and a stock ECU. Granted, it's a MAF calibrated for obviously over 2,500 horsepower. And on the stock Ford ECU running, this car does not have a standalone. They're out there making pass after pass, idling all nice in the staging line because it's MAF and not speed density. And yeah, so people that think that you need to go speed density to make horsepower, that you don't.
Are they drag and drive cars?
No.
I'm just curious.
No.
I mean, it's
not that I know of. So we sell a lot of stuff and I don't know where it ends up. So I don't know. A lot of people like Warren is doing, instead of running the car with the MAF, he's using it as a horsepower VE meter.
Yeah.
So it helps him fine tune his VE table, even though the car's speed density, he still has his MAF as a backup because that tells you VE. It's the air that's actually going in the engine versus how much it can technically hold at that time. And the difference is your load or your VE. So he uses it as another little gauge and a horsepower meter too.
Cool.
So you could use it for traction control. There's lots of different ways you could use a MAF sensor. So I don't know how people use them a lot of times. A lot of people don't share that stuff back with us because a lot of things are secret undercover, especially drag and drive stuff. A lot of people have their secrets. So.
Yeah. Fair enough. Okay.
This side to this side. Okay.
Jeremy's doing work in the background.
This just
He's the only one who works around here.
Well,
That's all
I
I'm
was gonna
saying.
say a filter would bolt to this, but you didn't put the holes in it.
What do you mean? What holes?
Holes for the filter.
There's holes for a filter on that. What do you mean? What are you talking about? Do you not know how this works? Oh yeah, you want that one.
Did you pick that right? Oh, you did.
Come on now.
All right.
There's extra holes.
All right, I'll give you that.
Alright, so what do you want to do?
This by itself. Okay. So hopefully it will center on the hole.
So I made an air intake filter adapter mount thing for the Jeep, and these guys are figuring it out for me.
It's about the same.
so duct tape that to this.
Yeah, cut like here. I'll show you the work this. I know how to cobble things.
All right, I'm at PMAS, and what they do is they specialize in airflow. So these guys are. I got my idiot friends.
There you go.
They're doing dumb
Take it
shit.
down like
I'm
that.
pretty sure you just
Put it on top. You need how do you tape this down?
Hold it still. Thank you. We did just do this a whole bunch of times.
So it's amazing what you can do with duct tape.
Right.
And these guys actually flow stuff all the time like this, and you wouldn't think it works, but it actually does. There's nothing wrong with it.
Not a damn thing wrong.
Nothing.
What is? I mean, duct tape is actually for ducts, so it's for airflow.
Right? It already knows.
Amongst other
No,
things.
this is actually duck. Like duck,
What type
duck,
of
goose.
video are you making? Oh, so you have duct tape can be used for all kinds of stuff.
It's not a porn, if that's what you're asking.
You went there. They're supposed to figure that out.
No, see, you got to tell your audience.
You gotta let them know what to expect.
You got to let them
Don't
know.
you have to change the settings on the video now?
Oh yeah, I'm gonna have to mark this as not safe for work.
Yeah, pretty sure. Well, thanks, Warren. Just cut the audience in half.
You're welcome.
Yeah.
I wouldn't say
increased
that.
it.
Or I would say or increased it, right?
Now I got to post this on a
All of
different
a sudden, a lot
site.
more people
I
just
can't.
joined in. You need to get the backside.
I'm working. Now you've done.
That's the first time Warren's ever heard that. That's too big, Warren.
Yeah, I'm really gonna have to edit the crap out of this video.
You guys are ruining everything. Ruin Christmas. Okay, stop.
Okay.
And the funny thing is you have to
pretty good,
tape it because it will try and lift off.
Really?
Well, actually, the air pressure pulling down through that will actually try and lift it.
Why is that?
Think about how a wing works.
Well, why don't you explain to your audience how a wing works?
It's because Bernoulli. Ask Bernoulli. Don't ask me.
I like how Warren tries to pass it off as the audience. It's really he wants to know how it works.
Damn straight.
By the way,
How does the wing work?
Because
are
it's
you
the low
doing?
side of the wing. When you put a bunch of airspeed over here, you have conservation of energy, right?
Uh-huh.
So that has to go somewhere, so it tries to lift the piece.
Oh, I get it.
That's fancy.
What kind of engineer are you?
What? Oh, that's.
I have people for that.
Hold on. I hit one.
He's one of them civil ones.
Lord.
He's a very civil man.
Exactly.
All right, so what they've got is they've got a big ass motor in the back, and they turn that on, and it draws a bunch of air through when they've got specifically calibrated nozzles. So those nozzles open up, they will only flow a certain amount of air. They group them together, and they use all sorts of computing to figure that out. So
Science.
and stuff.
This stand
So-
will flow a little over 8,000 kilograms an hour, which is 4,500 CFM per unit.
How many pounds per minute?
Yeah. So
How many horsepower can you make
How
with
many do you want to do on
4,500?
this? 3,000 on this one then too, or what do you
Yeah, I
want to
do
do?
3,000. I don't know. I need my calculator for that, man.
Is that what we did on the other one?
How many pounds
Yeah,
per
we did
minute?
on the other one.
So I'll tell you. You're asking this science stuff, Scott.
It's not really science. It's just I want horsepower, man. Come on.
It's 296 pounds per minute. So
So-
3,000 horsepower.
Yeah, 3,000 horsepower. So yeah, this airflow stand will flow enough air
There
for
you go.
3,000 horsepower.
So this test is called Scott's Hopes and Dreams meter.
I just hope it's not really bad. That's all.
It's gonna be loud.
So, Nick. All right, this test is going to run for a few minutes. I'll get back to you in a minute. So they just finished up the first test with no filter on it, and then you can see in the background there is a filter. So that's running again with a race filter on it. I don't know if you can hear what I'm saying or not, but you got to give this a few minutes and then we'll get some results. High level concept of how this works. You take, you go to a set airflow, you measure the restriction, you change that set airflow, you measure the restriction.
Yeah, so there's a couple
Yes.
different ways to do it. If I'm doing like testing things, I can do a solid state test where I say I need to flow. I work in kilograms per hour because it's a mass stand. I don't want anybody to forget and think that it's a CFM because that's a volume. That has nothing. CFM doesn't tell you the weight of the air. It doesn't take into account the temperature and the pressure and all that. This does. But I'll say CFM. So I'll say that somebody wants to flow 352 CFM. I can type in and flow exactly 352 CFM or 359 and then see what the restriction is there. Or in the case of a MAF, I can put that air and say, okay, what is my MAF output at exactly this airflow? So I can do it at one solid state test and then do tweaks. So like if I'm porting something, I can put it on there and keep checking that same airflow and watch the pressure change and know that what I'm doing is working in my favor.
Duct tape and bubble gum.
Yeah,
until it
whatever.
works exactly
You have
how you want it
epoxy
to.
welders or whatever,
Yeah.
and it might not be the same at some really low airflow and some really high flow. So I can check at all these different places and see, hey, I helped it here, but I screwed it up on the top, and maybe that isn't a trade-off that I'm willing to do.
Right.
So you can do that with it, or I can do, like I said, a multi-step test where you turn the machine loose and it'll start at really high flow and then work its way all the way down and take pressure readings at a whole bunch of different flows, and I can pick what those flows are. I'm not stuck with one standard thing, or like I said, like a super flow type stand, you don't get to pick. You get, this is the restriction, here's what the flow was at 28 kind of thing.
Yeah.
So I get lots more data, and sometimes you'll miss things. If you're only looking in one place, what you did might have helped here, but somewhere at peak torque where you really want to have the gain, you might have lost something there, and you don't catch it because you're only checking at a really high airflow.
Yeah. It's like bad cams from the 90s.
Yeah, exactly. 3/4 race cam.
3/4 race cam.
Some of those will jump a pop cam with the front
At
wheels.
least one pop can. So.
Yeah.
Okay, so I just got the results of the filter mount, and yeah. So Jeremy, help me read through this. Just real quick. Really, what do we need to know?
The filter creates a little bit more of a restriction than without the filter.
Okay, and a little bit meaning like even at the top flow, it is.
I mean, you're talking what, 5%?
One inch of water, dude.
It's
So-
not even 1 inch.
So-
It is.
No, it's fractional. At the very, very top, at
It's
2800.
4/10 of an inch of water.
So if anybody, 4/10? So
4/10.
At almost 2900
So for
kg per
nerdy
hour.
people like me that want to know that in American unit.
That's 1.4, not 0.4.
What? Oh, sorry, yeah. So in American
Point
units,
doesn't matter.
that is
Always
point.
check.
The difference is 0.014 psi.
So 0.014 psi, which is how many horsepower? Anybody?
Like I don't know. I only know llama thrust. So
Well, it's a tenth of an atmosphere, so a tenth of whatever it is.
it's like Jack Dillon shit.
Yeah.
It's basically nothing. But what this does, So almost no flow restriction versus just not having the filter on it at all, and it's not coming off all by itself. So
It's taped.
It's taped. Oh yeah. So basically, a bell mouth that's open. This has a very negligible effect. Like, it is measurable, but it's virtually 0 horsepower. But this will save my turbo from rocks and stuff, which is like really important when you're driving 1,000 miles on random roads that they send you on drag and drive. So
Got my logo right there, right?
oh yeah, there's your logo. Yeah. So anyway, thank you, Nick, for letting me borrow your test stand and for flowing this stuff for me, and just being able to prove that, like, no, this is a Jeep mount. This is for the turbo for the Jeep. It should be sweet for me. So getting it back on the car and we'll go.
So what are you flowing?
So actually, I had to, well, now I put it back together, but essentially what I did was,
Here, we got it.
thanks. So the mount for the Jeep, the Jeep has some really tight engine bay restrictions. So I had to actually take, I wanted to have something like or an air filter or something like that. So,
You have like some apparatus that's got chicken wire in front of it.
I didn't want to do, I wasn't going to do chicken wire.
Okay.
So what I wanted to do was make sure I had some protection, because we take the Jeep on drag and drives. We built it for drag and drive stuff. So what I had to do was, PMAS makes a modular air intake system, but I couldn't use their stack. So their stack, I think he's got one over here. I'll grab this one because it's empty. So yeah, this is their regular stack, and you can have any sort. They've got like these mesh filters. They've got like mesh race filter. Ooh, sorry, touching you in a weird spot. They got these mesh race filters. They got some standard filters that are a little bit more like the K&N filters, although they're unoiled, right? So they are a little bit
wet or dry.
We have
wet
both.
or dry.
When you
So unfortunately, with the depth here on their regular modular stack, I was unable to fit that on the Jeep. So what I did was I actually designed up a new one for myself. This actually bolts to the front of the turbo. It's printed in a high temperature FDM filament, so it should not melt. It's good to about 340 Fahrenheit. So if it melts, I have some other things going on that I might want to address first. And so what I did was I specifically made it for this mesh filter so that I can have a mesh filter that is on the turbo while I'm doing a drag and drive, and hopefully I never have to take it off. Hopefully I can race with it. And as long as I'm not making too much power, I should be all right. But essentially, I came here today to actually flow test this because I had an opportunity to do so. Nick invited me out, so thought that I would do that. And then I ran into these guys.
And we were trying to flow one of these things, where it's basically chicken wire in front of really small turbos that don't belong on cars.
Now, did you get that one in China? It looks like the Chinese
chicken wire one.
That is the chicken wire.
That's the improved chicken
So
wire.
this is a chicken wire one. This is from a Home Depot Racing with some glue.
Boy,
wire
Home
one.
Depot Racing, they did a really good job on this one. Did you guys know you could pick this stuff up at Home Depot? That's some...
You guys would laugh at the difference. So that one,
Okay.
so
So which one?
real quick. So that one is
This one.
at like 2,700 kilograms an hour, whatever. So
So
much airflow.
hold on. So like this is a
that's
flow
wrong
test.
one. Yeah.
Right? Flow test. 37 points.
It's like a dyno sheet, but for
For
airflow.
airflow.
Yeah.
So that one pulled 30 inches at 2,700 kilograms an hour. So like a little over 1 psi. The new and improved super awesome one
This Home Depot Racing one.
pulled 27 inches, which is like the same thing. They both suck. Having literally nothing on the front of a turbo is 25 inches. So they're horribly restrictive. And then Scott, why don't we show your thing? And yours, how many inches of water?
This was Hopes and Dreams. So this is without... Wait, hold on. That's no filter. Let me get the one. So my Hopes and Dreams are just the Hopes and Dreams are just the stack itself. So you were at where? You were at
Which one do you want?
any
Nothing?
the better flowing one. We'll be nice to him. The 27.
Nothing.
Oh no. Okay.
Nothing is 27.
Nothing is 27. Mine is 14.7.
Yeah, no, I'm sorry,
what
I
is this in
misspoke.
here?
I misspoke. Nothing is 25.
Nothing is 25.
The honeycomb is 27, and the wire mesh is 30. So having nothing is 25, and yours versus nothing.
Is 14.
So
is just a-
considerably
that
less
is
restrictions.
just 14.
And then with the filter,
I'm gonna get
With the filter
hopes and dreams with filter.
is 15.
Yeah, 15. So nothing is 25 inches. The honeycomb screen is 27.
So
And the wire
this is
screen
the honeycomb.
30.
No.
Yeah, that's
This is the
honeycomb.
20. This
27.
is 27 and this is 30.
Yeah.
Can you?
Which is the next worst one?
Do you know what this is, Nick? Off the top of your head?
Yeah, hold on.
You got a.
No, off the top of my head, I got a piece of paper that tells me. So 1 second. quick about this. Quartz modular base only 13.75.
13.75.
Yep.
Okay, so it looks like here. I'm gonna throw this way. Yeah, you won. You won versus over me. Yeah, sorry. So nothing is basically right here, I think. So this is the most restrictive right here. This is a little less restrictive. This is a little less restrictive. This is less restrictive, and that's the least restrictive. And even with, do you know what yours is with the filter?
Yeah, the same as yours.
It's the same. Okay.
Yep.
So basically, with the filter, these are actually here. I'll move that down a little bit. It's about there, basically.
Yeah. So
Yeah.
the funny thing is you could have that screen on it, and it's less restrictive, considerably less restrictive than both of these clamp-on turbo.
No,
Well,
the Home Depot Racing.
Yeah, Home Depot Racing screen.
Engineered
And
stuff.
really, you'd probably put them more like
Yeah,
that.
honestly, like for real,
least
yeah.
restrictive to most restrictive.
Yeah. Yeah.
Because there's a big gap here.
Yeah. Well, the point is, if you can have a screen and a filter on the end of one of these that's less restrictive, why would you even use this?
Well,
there's no point.
Well, I know you and I have talked about this, but for people who are watching and for Warren, because I know he hasn't heard this yet 5 times. What is the reasoning for these being so much more restrictive than these?
Well, if you think about it, if you smashed that down to, like, all that metal down to one solid piece, if you think about it, it would plug like a third of this turbo inlet with steel. If you smash this all down, you're covering all that. The same thing applies here. So what we do by doing this is you just get more free area. It's not like this screen is any less restrictive than this screen. There's just so much more screen that you end up with more free area that's not blocked by metal.
Yeah, so effectively what's happening here is regardless, like if you put something in front of an air inlet, you're gonna restrict it.
Yeah, of
There's
course.
gonna be some restriction. But you're making up for that by making a larger air inlet effectively.
Yeah, it's just
So
bigger area.
you've got, like, what are these, 4-inch? Are these even?
4 inch, yeah, they're 4 inch.
So you got 4 inches right here, and let's say 30% of it's blocked here, and let's say 25% of it's blocked here.
Yep.
Well, this is a whole different game
You have
because
it blocked, didn't you?
this is a 120 millimeter
Yeah.
inlet, which is the size of this. And yeah, you've got some blocked.
Well,
but
then you
even-
have all this pleat too, which doubles the surface area.
The
So
pleat- that's another
you
thing.
really have more free area with this than you do with nothing.
Right.
If you think about it, it's like having nothing on it.
Yeah, yeah. Well, effectively, that's what you're seeing
That's
in these.
why it shows in the flow test.
That's why
It has
the
hardly
the
any-
lower number this pressure drop is, the less restriction you have at a certain flow rate. So you can see your flow rate, and this is in kilograms an hour because the rest of the world runs on metric. And then for some reason this is
It's
in
not
each
metric?
row, so it's fine. But essentially you can see what your pressure drop is at a certain flow rate. And so a higher pressure drop, a higher number there, is going to be a more restrictive flow.
So more pumping losses, more horsepower lost to move the air instead of spin the crankshaft.
Right. So yeah, there's a lot of people who run like these.
Don't. Just don't.
Yeah, I mean,
Run a smaller
it's
turbo.
not even better than nothing.
It's not.
Very
it's actually
honestly,
worse than
the
nothing.
only thing that benefits you is that, like, anything bigger than a very large honeybee can't get through into your turbo.
Well, and that's big enough that anything that makes you through that is going to annihilate the wheel anyways. Like, it's nothing this will stop things that'll hurt the compressor wheel. It's not. It
Yeah.
stops rags, I guess.
Yeah, you're not going to suck in rags, you're not going to suck in squirrels, and you're not going to suck in.
I'd rather suck a rag in than a rock, honestly. But
That's what she said.
But that's for another episode.
Yeah, we're going to have to post that on a different
Channel,
a
different
different
channel.
video sharing site. Anyway, well, yeah, this is awesome. Is there anything you want to tell any of my viewers, anybody else? Or
some cool other information, the blower. We haven't talked about like the size or anything. So the blower that runs this thing is an electric motor that's 250 horsepower.
yeah, I've got some B-roll I'll throw in here.
Do you? Yeah, it's some big numbers. The power company loves us when we turn this thing on because
I'm sure they do.
Our power factor's through the roof, so it's pretty cool stuff. So this is the dark dingy room.
There's 2 motors that Y into one big pipe. What, 12-inch pipe? 10 inch? It's at least 10 inch.
10 inch on the big one.
10 inch on the big one. And it's a small one you probably use for like normal stuff,
Yeah.
and the big one you get going when it gets serious.
Today we even fire up the big one. Today we were running off this one all day.
Even on Ram Kumar's setup. Yeah, I see.
This one's about 40 horsepower. It's a 5-stage centrifugal. This one is 250 horsepower. and it's a 7-stage centrifugal. So this motor runs at about 250 amps at 480 volts. And this thing, when you fire off the motor, it pulls about 1100 amps
At 480, I
at
assume.
480. That's 528,000 watts.
Yeah, so, yeah.
528 kilowatt. Just as more than most city blocks.
Yep. And I mean, you've even got like fire suppression in here just in case some shit goes down.
Yep, because this would be a bad thing.
Yeah, yeah.
Yeah, what's that?
But this is basically like the engine room of a ship.
Mm-hmm.
So these are exhausts. These are not intake. Like
That's
the
exhaust.
the intake is here.
Yep.
It's
and
this
that's
part is
exhaust. They pull a
intake.
suction.
This big hole blows air out of it. So yeah, that's how they actually power the flow stand that's in the other room. So
But no, we do a lot of things. Any special application for a MAF will work with you. If you've built some funky intake and it's a MAF car and you want to know, you can send us the stuff that you built with your OEM MAF if it has the range, and we'll flow your concoction and give you the data off that so you can put it into your tune because you've made your own DIY coiler intake. That's fine. We don't care. You don't have to buy our stuff. If you need more range, you can buy one of our sensors, build your setup around it. Then when you're done with everything, you can send that whole assembly back and we'll flow it for you too, and it gives you the data to put into your tune.
Yes.
The tuners love that. It's a big deal.
you can actually calibrate an individual intake for an individual car.
Yep, absolutely.
Yeah, completely custom intake.
Yep, completely custom. So you want to whittle your own thing. You don't have to try and spend all day on the dyno and guess what the MAF transfer function is by looking at your fuel trims and change the number and try again, change the number, try again. We'll flow it and we'll give you the data, and you start with the right number so you already have that, and that's done in the
Cool.
tune. Saves a crap load of work.
That's cool. Yeah.
Yeah.
So yeah, if you're a tuner, even if you're a performance enthusiast, you need. It sounds like stock replacements, performance, and even custom stuff. You guys can get people
Airflow
squared
testing.
away. Yeah,
and airflow.
testing
If you
too.
just want to test some part that you've built or an intake manifold or whatever it is, we can just do restriction testing. All the MAF stuff aside, we can tell you what the thing flows or how restrictive it is, or if you've tweaked something, if it made it better or if it made it worse.
Sweet. Okay, cool. Well, yeah, that sounds sweet. Thanks for meeting with me today, and
For sure.
just going over what you guys do here. This machine is bonkers, guys. When you start thinking about all the things you can do with it, you're like, oh yeah, I'm gonna flow test my socks. Like it's just like all sorts of dumb stuff. And so yeah, you can kind of go pretty far with it. But you know, if you do have a crazy application, hopefully it's better than socks. Give PMAS a call, and I'm sure Nick can get with you and get stuff figured out. So. Thanks for meeting with me,
Yes,
man.
sir.
Yeah.
Good talking to you, man.
We'll see you. Bye.
Sure.
See you guys.